Hello. Good morning, everyone. I'm here to talk about Docker security for developers. Just to give you a background, this picture, is actually a picture I found last year. It always reminds me that we haven't been making large, complicated systems just recently, though. We've been making them for a long time. This picture is about from an advert about 100 years ago for a steam engine components manufacturing plant, and so I kind of complicated systems are not new. We're not. There's a lot of history we can link to, but I'm not going to talk about that too much today. I work for Docker in Cambridge in the UK, and I'm a maintainer on the Docker engine, so feel free to ask me all sorts of general Docker questions later on, as well as security-related questions. I work quite a bit on security-related things, but also other bits and pieces. I've worked on Docker for Mac, Docker for Windows, and products like that as well. So if you've got any questions about them, you can come and harangue me later. The Cambridge office is actually one of our two European offices. We also have a Paris office. So Docker is a European company in origin. It was originally founded in France, and so it's nice to be part of Europe, and there are quite a lot of people based here. Before I worked at Docker, I wrote an eBook, helped contribute to an eBook on Docker, particularly writing about security. It's kind of old now. Docker moves quickly, so it's not the most up-to-date book on Docker, but if you're interested, you check it out. So I'm going to talk about security for developers, because sometimes security seems aimed at production people, and I think that there's a lot of reasons why developers should be concerned about security. Things have really changed in the last few years in particular. Production and development are not really silos anymore. You don't just write some code, throw it over to your operations people and say, run that, and never hear anything back again. We have DevOps, which is originally created in Belgium, and we have DevSecOps, which is development and security and operations all working together. The aim, is to have teams of people working to create quality software, and understanding that some people might be more expert in one domain or another, but we're all trying to build something that's as good as possible and that meets the objectives of the project, and and security is an important objective. Lots of there are people trying to hack your software all over the place for all sorts of different reasons. They might be doing it for money or for vanity or for just as a way to hack someone else or whatever it might be. There's lots of reasons, and no one's immune from hacking attempts. And often the severity of these is pretty bad nowadays, and you want to try and not be the person who causes these problems, and as a developer, that's your responsibility too. And part of this is security as a process rather than just a kind of we've built the product, and then at the end someone asks, is it secure? And you say yes, and that's the end of it. You need to be constantly thinking about security as part of your development process, and learn from mistakes as well, rather than, when something does go wrong, rather than blaming someone for it and just saying, yeah, your code was terrible, someone hacked it. Just learn how you can improve in the future. And there's a lot of things in security that are good practice that aren't everywhere. Not everyone does them. And we can one of the things that I'm going to talk about later is just how we can actually spread good practice across software we're developing. And although this talks kind of about Docker, many of the important things are not actually about products at all. They're about process and people. So the first thing to think about when you're thinking about security is, how is your organization set up to do security effectively? One of the key things is try and, if your organization is, if that's possible in your organization, try and embed security people in your teams. For example, at Docker internally, we every product that we build has a security person assigned to it who comes to the meetings and tries to understand what the security issues are with each product. They spend more or less time at different stages in the product. Some parts of the process they're not needed much, but some parts they feed in really important and crucial design decisions about how things should be done, how authentication should be done. Look at the whole structure of your code and understand where the security issues might be. And it's incredibly valuable to have those people available and not just sitting in a department of security people who you don't talk to. So try and get a security person on your team for your project. Even if you just get a little bit of their time, it's better than nothing. And then try and make that a kind of the way things work. Make sure everyone understands. Once you have a security person or someone whose responsibility it is, make sure that everyone else in the team understands. What they're thinking about this project is, where, what they see as the risks and what the threats are, and so on, so that everyone has that in the back of their mind when you're developing any code. That I'm touching something that's we thought about that is important for security. And postmortems as well. If something does go wrong, don't just blame someone for it, but sit down, have a meeting, discuss what happened, how you're going to change not just the product but the process so that you don't end up where you did. Understand what kind of testing you were missing that could have caught that. Come out of a postmortem with actionable items that you can really implement, and make sure that you do implement them, and that that every problem is a part of a learning process and a way to improve. So the organizational bits, really think about these long before you actually think about any code or any tools. People often start with tools, and tools are the wrong place to start. Tools are kind of where you go to after you've fixed organization. Security tools can be kind of terrible. One particular thing that comes up with some tools is that they automatically generate 100-page PDF documents that they think you're going to read, which is incredibly unhelpful because no one ever reads 200-page PDF documents, and automatically generated ones are even more boring than anything else that you've ever read. You actually want actionable test cases and things like that. Tests that are passing or failing, or why they're failing, and not things to read. Testing for security is something that people often don't do nearly enough of. But like any other kind of testing gives you the confidence to make changes and know that you're not going to break something. And knowing that you're not going to break some security thing is kind of really, really relaxing, that you can just not worry about it because you know that the tests are there and they're going to test that the important security properties of your code are unchanged. So even basic things like making tests that make sure that you're running SSL on your connections and so on. Like just you didn't accidentally change an option that turned SSL off somewhere. Just even basic things like that. It doesn't have to be complicated testing, but just having tests is just one of those relaxing things as a developer. I highly recommend this book. It's just come out. If you've read The Phoenix Project, it's written by the same people as that. They're really nice people and very good. They spent 5 years writing this book, so it's worth spending a few hours reading it. It's got a whole section on security, which I recommend you read. It's a really good book, just out a few weeks ago. Slightly just about available, I think. My copy arrived a couple of days ago. How does Docker help in all this? I mean, Docker's it's a tool like any other tool, but I think it's not going to help your organizational process necessarily. But I think what I'll talk about in this talk is some of the things that we try and do. Part of this comes from the philosophy we have at Docker, which is to try and make security usable, because security is one of these things that if it can be a really complicated option. You can have if it's incredibly complicated to use, basically, then no one will actually do anything. So we really have this aim to try and make the security options usable. I think, this is difficult because a lot of the stuff we're dealing with is kind of quite low level and technical, and I think there's a load more work we can do. If you're interested in helping out, remember Docker's an open source project, and contributions in security are incredibly valuable, and a lot of the important developments have been from contributors from all over the place, and they've helped make it a better product. So if you want to work on this and you're interested in usability of security, there's loads more work we can do, and loads more stuff that is going on. Come and talk to me if you want to, if you have things you're interested in and want to work on. This is from there's a really excellent report on security of containers that I accidentally haven't referenced here, but one of which compares Docker against other container runtimes, and as you can see, the particular bit we're probably most proud of, I'd say, is the bit saying strong defaults or default. These are areas where out of the box it does the right thing, and we really try and make those things work for users completely. Just as you install it, you just get these things, and you have to really try hard to not do the right thing. And over time, we hope to change some of the things that are optional or coming soon to also being strong defaults. We'll get there. We'll get there soon. This is Docker 1 for Docker 1.11. We're still working on these things, getting them to be better. But yeah, strong defaults is what strong defaults and ways to tweak it to make it even stronger if you can. So we kind of like to divide Docker into build, ship, and run. So in terms of security, I'll talk about the three phases. So as a developer, when you're building things, we spent a lot of time on the Docker official images for different things. These are there's a whole team of people who work on official images, and they spend a lot of time making sure that these are a really good point to start from if you're a developer. So if there's an official image available for what you're using, I strongly recommend use it. The first thing with the official images is that they get updated for security issues really, really fast. There's a team that sits there and basically looks at every security issue that comes out. So if, for example, the container's based on Debian, they'll look at every security issue in Debian and make sure that it's fixed, usually within hours, as in the official images. So you can be absolutely sure that that the security, that any base image security issues are fixed, or anything, when if there's an issue with the Java runtime you're using, or if the MySQL database you're using, whatever, there's a security issue in that will be fixed really, really fast. Or if there's an issue in some dependency that the thing drags along, there was curl. The curl tool, for example, had 12 serious security vulnerabilities a few days ago. But curl's bundled into all sorts of tools, and there's a dependency of all sorts of things, so those get updated really fast, and it's so that as long as you rebuild your Docker images from the official images, as soon as they get updated, that you'll have security updates. They also try and have sensible security defaults built in, and they try to be as configurable as possible. So you can override any of the things in as you use them. So even if you don't use them, they're worth actually looking at to see, if there's some reason why you need to do something differently for your container. At least see what's there, look at the guidelines, and have a look, but also make sure that if you build images yourself, that you understand how to do, that you've got timely security updates and so on. The guidelines are kind of really helpful, and there's actually a huge amount of work which is kind of invisible that goes on there, making sure that those are as good as possible. They're also all open source. You can go, and if you've got a problem with them, the Docker library is the GitHub repo where everything is, and feel free to raise issues, complain about the fact that it doesn't do exactly what you want or whatever, and contribute fixes to if things are not how you need them to be. For Java, there's a lot of official images, both for OpenJDK and for IBM Java. There are currently no Oracle Java official images because of the redistribution things. That may well change at some point, but I'm not sure about that. But generally, there are lots of unofficial Oracle Java images on Docker Hub, but for legal reasons, I wouldn't recommend you use them. There are generally, for a lot of the official images, there are two sets. There's the ones based on Debian or Ubuntu, and the ones based on Alpine Linux, which are generally much smaller and more lightweight. If you can use the Alpine Linux ones, by all means, do save hundreds of megabytes of downloaders every time. It's always makes life easier if the things are smaller, and generally the Alpine ones, as well as Alpine Linux is just smaller, are also tend to have a more minimal config. If that works for you, that's great. If you need absolutely everything, you might need to use the other ones. So you've built your software kind of in Docker, whatever you're there. Next thing, you want to ship it. Docker spent a lot of time working on Docker Content Trust and the Notary tool, which is basically an image signing tool that you can use for all sorts of image signing. It's based on a specification called the Update Framework, which was originally designed for updating Tor clients. So basically, the Tor browser bundle basically looked at the way that image signing worked for things like package management, and which generally uses things like GPG keys, and decided there were a bunch of problems with it. One of those problems, for example, is that once you've signed something, a version of a package, it remains signed forever, and so someone can give you an old image, maybe change its name and pretend it's the latest version and say it's a signed package, run this, it's fine. But actually it's a signed package with a security vulnerability in it was fixed a long time ago, but this is an old version. It was signed at the time, but there's no way to undo signatures. So Docker Content Trust and TUF basically have a timestamp on the signatures, and you can basically invalidate them, and so that there's a window of time after which basically you can be sure that old packages are invalidated. It's kind of, the specification's kind of complicated. If you're interested, there's a website, the updateFramework.org, I think, which goes through the specification. But it's relatively easier to use. We've been kind of rolling out support gradually. The next stage of it is that at the moment all the official images are signed, and the next stage, which will be turned on, is that Docker will always check the signatures for the official images. But a lot of people are starting to use signing for their own images, and there's a whole set of things you can do. So you can, for example, have multiple signatures on a package that signify that various different stages have happened. So you can have the CI system sign the package to say that it's actually passed its tests, and then you can have different people sign it, and then you can have your release process check that all the right signatures are there and reject going into production if it hasn't been through all these processes. So you can build process around validating that the code you're running has gone through the right processes. And you can have, I've got a YubiKey here, you can use YubiKeys to do hardware token signing, for example. So you can make sure that your keys are not compromised, and there's a whole growing set of process and tooling around this. Do come on, if you're kind of interested, do come and do talk to people who are working on this. We can get in touch and look at the tooling. But so as part of our default security thing, that the next stage is that official images will only be downloaded if the signature matches. At the moment, you have to turn it on explicitly yourself to check, but that's going to be automatic soon as part of the whole let's do default security correctly idea. And then gradually we're going to encourage people to enable it by default for their production systems and so on. So as a developer, think about image signing and the process and how you might want to incorporate this in your processes. Image scanning is also this incredibly useful tool. It's still in free trial on Docker Cloud, so if you create an account, you can sign up for the free trial and try it out on your own images. Basically, it's there's a few other products that do this as well. But the service on Docker Cloud I recommend you look at just to try out how it works and see what this tooling can give you. Here's an example of an image I picked up, which is I can't remember what it was actually. But if you go into Docker Cloud, this is the interface you get. It'll show you basically if the image you've uploaded has any problems, and it'll tell you exactly what they're in and what they are. So this image had problems with Perl, glibc, and util Linux. and no problems with the other things. And so it's got this critical vulnerability from 2013, which hasn't been fixed in Perl, and some critical vulnerabilities from 2013 and 2014, which haven't been fixed. And you can upload basically any Docker image you like and have it scanned, and just you get an output like this. It's basically incredibly useful in order just to see what's going on. Often you don't even realize all the things that are inside your image because they are dependencies of some other tool, and to have great, clickable, detailed information on what the actual things that are inside your image are. It also gives you, as a bonus, it gives you the licenses of the components, so you can see if you're respecting the license terms of the things you're using as well, which is kind of useful. These images are rescanned on a regular basis, so if new vulnerabilities are found, it'll highlight them later on. There isn't yet an API, but hopefully there will be one soon, so you could incorporate this into your CI flow and make it check to see if there's vulnerabilities in your images. At the moment, it's a manual thing. I think they're working on an API. Known issues are a huge problem. A report in 2014 said that looking at data breaches found that 97% of them were accounted for by already known about issues, and 88 of the issues that caused the 97% of exploits were over 10 years old. So these are things even older than these ones, and also organizations use a huge number of components. The average organization according to the study used 18,000 different components, of which only 7.5% had known vulnerabilities, but that's an awful lot of different components. And so this kind of tooling really gives you something that you can actually just look at and go, okay, this is the 7.5% of things, and these vulnerabilities are 10 years old, and I can fix them. I can just update these components that we're using. It can find things. It can find components however they get into the image. It can find things that are statically linked. It can find things that are dynamically linked. It can find things that are embedded inside another binary. So it actually scans the binaries and looks for the signatures of things. So they don't have to be things that you think you've installed. They can be things that have accidentally got or installed by a dependency that you didn't even know about. Because lots of components turn out to maybe use embedded SQLite, for example, as a common one, which has had a bunch of vulnerabilities. So you can. This stuff is actually not that hard to fix. It's really just a matter of being able to knowing there's a problem and being able to just rebuild that, and then that actually gives you a huge sort of peace of mind that there aren't known problems that are caused by other people's software making your software exploitable, and so that kind of it's just having these tools just easily available. Just click on, have a look. Is really useful. The API would be even better. I'm kind of trying to push them to sort out the API soon because I really want to use it for my stuff. Then runtime. The number one thing probably is don't commit secret keys for your services and things into your source code repository. And don't commit them into your image at runtime either, if at all possible. Make sure that they're as well hidden as possible. Try not to put them in environment variables, because you can read environment variables for other processes quite easily. If you've got any kind of root access or access to that user, you can read other processes' environment variables. There's a bunch of key storage mechanisms, HashiCorp's Vault is probably the most widely used. What these do is basically give applications an API that they can call to get hold of secrets that they need, and the secrets are stored encrypted. The applications are time limited on the access they have. There are APIs for all sorts of languages, so it's really easy to implement. And it also deals with things like key rotation. So, for example, you can make sure that all your SSL keys are rotated automatically, and the application can get new ones without having to build all that into the application. The next release of Docker is going to include built-in secrets management because we like to make things even easier for you. I think it got merged last night, but I'm not 100% sure. But it's kind of we're just in the feature, just about to enter the feature phase for Docker 1.13. But the initial part of this is definitely getting in. There's more bits to come, which we still need to work on. This is secrets at runtime for Docker Swarm services initially, but it will be expanded to cover Docker Run and Docker Build, because lots of people need to do things like add keys for accessing things at build time as well. We know that you need that. This is what the interface is going to look like. You're going to do Docker secret create, say, to add your SSH key, and then you can create a service with that secret, and then the service can find it in run secrets in the file system, so it can find that key and use it. And then you can, the keys are only stored in a read-only memory file system, so they're never committed to disk. They're stored encrypted inside Docker and distributed using the built-in Docker Swarm SSL encryption that it uses for everything, distributed to all the different nodes in the cluster. And you can also update them later if you need to rotate your keys or anything like that. So the idea is to try and make it as simple as possible to use, and you know, it's you still may you can still you may want to use external tooling like Vault, but you don't have to. Potentially, you can use the built-in tooling as well. So there's something built in you can use. You still might want to use Vault because it's got extra features or something, but at least there's an option that's better than sticking it in environment variables or committing it into your image or any of those kind of mistakes that that people tend to make. Well, or if people don't have any options and it's difficult, people go with the easy option. So we want to provide an option that's so easy that you don't have to do the insecure things. The kind of guiding principle that you need to think about when you're thinking about security is least privilege. Don't give any program more access than it absolutely requires. And this is something you always need to think about: is, you know, what if you give a program more access than it really needs, then when anything goes wrong, people can escalate privilege through that component. You know, so if for example you're using AWS, there's a whole access control thing, but you know, if your program just needs to write to an S3 bucket, just give it access to that one S3 bucket. Don't let it be able to create more EC2 machines on EC2, and you know, things like that. So always try and think about a way to just give a component the access it actually needs, because then it basically means that when things go wrong, it can't do anything that it, or if someone gets access to it or you can use it to do something else, it can't do anything. but obviously to do this, you need to understand exactly what your application requires and needs access to. And I think that one of the nice things about microservices and small services is that it makes your code actually understandable as a whole thing. So you can sit there and you can actually understand everything that your component does, because your component isn't doing it's not a huge monolithic thing that's doing what does this do? Well, it does everything. It accesses this, it creates these, it talks to these 300 different services. It needs to be able to do everything. Generally, a monolithic service does need to do everything, talk to everything, and have all the privileges because it's monolithic and it does everything. Microservices are great from this point of view because you can look at them and you can say, this component sits in between these other components. It gets input from this one. It talks to these three. This is how it authenticates to these processes, so they know it's the right one. This is what it needs to connect to on the network. And you can probably write down, if you can write down on a page everything it needs to do, then it's much easier to understand how to do least privilege. I think that microservices are really, really beneficial from this point of view. As a kind of, I can understand what things do. I can write it down on a short piece of paper. We can all look at it and say, well, this is how we make sure that it can only do these things that are on this list, and how we can add tests that it is only doing those things, and how gradually over time these things might change because we modify our code, but the change process is manageable because it's not really doing too much. Being able to in your head know when you're working on one thing, the full collection of things it actually does. Also makes tooling easier. You can kind of use automated tools to understand this. So you can create this sort of checklist where you can list every other service that your service connects to, whether it's whether it's inbound or outbound. You can look at what authentication and encryption is used on these connections, where the keys come from, where the access tokens come from. You can say which untrusted user data are we getting in these things, because a lot of vulnerabilities come from accidentally trusting what should be untrusted data that comes from potentially an attacker. So is your service exposed to the outside world, or somewhere where there might be some degree of some amount you might not trust it, or some way that some user could put data in. If it's got a public HTTP endpoint and you're talking to it, then you must be extra careful about those requests because the user could change them, so they've got unexpected items in. What kind of secrets? What secrets does this particular part of the service need? What as I said on AWS, what does it need to be able to do? Does it need to just access one S3 bucket, or does it need to write to other ones? If your service needs to do lots of different things, if you look at this and this is complicated, it doesn't fit on one page, then maybe it should be more than one service. Maybe it's a good opportunity to break it down into something smaller. If you don't know the answers to these questions, again, it could be a good time to do a code review, try and understand a bit better what this code that you've inherited is. Maybe it's some code that's been around for a long time and you don't really. When you go to work on it, if you don't immediately know the answers to these questions and they're not in then there's no documentation in the repo. Maybe it's a good time to write some documentation and sit down, look at the flow, look at the connections, and try and understand what it's doing, and then look at look at what secrets it's actually getting versus what it needs, and see if they're too broad. I would see if there's cases where there's untrusted data coming in that you're not being careful enough. So basically, spend some time reviewing the code, understanding what's going on, and then containers are a great way of implementing least privilege, and I think that's is kind of important. The first thing containers do is they restrict access to files to just the ones inside the container and not everything on the host, which is just a simple example of least privilege. It doesn't need to access access files on the host. You have volumes and you have the local files, and they have everything that the container has. So containers are, in many ways, a good kind of automatically implement some parts of least privilege. You have to explicitly publish network ports with Docker, otherwise it doesn't have external network access. So you've got that point where you can look and see which ports are being published, and you say, oh well, those are the inbound connections. These are points that we have to look at from a security point of view. Let's review what these connections are. They're not a magic thing that will solve all your problems about security at all, but they will help you along understanding how this process works, how your software is working, what it's actually doing. If you're not using Docker and you're thinking about it, that process of actually putting things into a container and working out which ports to publish and things will help you along with this process a little bit, and looking at what's in the container. Does it have stuff that it doesn't need? Why are we building so much stuff into this container? It should will also help you do this. Another thing we spend a lot of time doing is working out some intelligent defaults for containers and ways to customize it if the defaults don't work for you. We have a whole bunch of tools, which I'm happy to talk about in loads more detail if you've got questions. So we filter some system calls if you don't say that explicitly that you need them, to make sure that your container can't do things which are, for example, normally only used by Linux kernel exploits. And so if someone's managed to hack into your container and is trying to do these things, we will often, not always, but often have protected you through this. We have a list somewhere of known exploits where we either have or haven't mitigated it through our security defaults, and we kind of look at every time there's a new Linux kernel issue to see if what we were doing helped you or not, and what, again, how we could, and we have discussions about whether we could have done something about this that we didn't. We try and have a little mini retrospective around the major security issues in the Linux kernel, and whether there was something we could do. Whether it was something we could do longer term to mitigate this kind of exploit, and sometimes there is, sometimes there isn't. But it's a part. Again, it's part of this ongoing process of trying to make things work for the user. We apply AppArmor or SE Linux profiles if your Linux distribution you're using supports them. Generally, Ubuntu uses AppArmor and Red Hat uses SE Linux, so it's kind of a bit fragmented. So we have to do different things for different distros, and they protect you in slightly different ways, which is not ideal. We also try and protect you even if your distro doesn't use either of these. We restrict the Linux capabilities, which are basically kind of different aspects of privilege that Linux gives you. You can add more if you absolutely need them, but try and avoid requiring anything that's non-default, because the defaults are are there to help you, to help your security, and they have kind of subtle ways in which you can escalate privilege quite easily with some of the things if you change them. So if you use the Docker run minus privileged, that basically lets you do anything, but you really shouldn't be doing that in production. It's a useful development tool, but it's really not helpful in production at all. There's also user namespaces, which are, I don't know, Phil is around somewhere who worked on these, who works at IBM. These basically let your container think it's running as root, but it is not really running as root. So again, it's reduces the amount of privilege, but still kind of lets it do a certain amount of stuff that's more privileged, but while actually reducing its privilege. The report from Gartner said that applications deployed in containers are more secure than applications deployed on a bare operating system. I think all these defaults and the actual structure of containers, they don't a complete, they don't solve all security problems. As I said, most of the security problems are about process and things that you need to solve as a developer and as an organization. But containers definitely help. Companies like IBM are deploying container-based public cloud, which is probably the most hostile environment where anyone can run any code. And they're happy to do this in a containerized environment with the right configuration and setup. So there are always security problems, but containers really can help you along on the kind of security journey, and they're probably the easiest way to kind of get started and start thinking about this process because of all the things that we've tried to build in. But never forget that it's all about your development process, the problems that your particular application has, the risks lots of security issues are completely unrelated to anything a container can fix. If people can, talk directly to your database through your website and access things through, SQL injection attacks or something like that, then nothing is going to help you, and you need to spend time thinking about, as I said before, about what's untrusted data, what's coming from the user, what kind of access does your website have to the database? How restricted is it? Can it do anything? Can it, does a component just need to be able to read stuff from the database, or does it have to have write access? Can you restrict the write access? Can you at runtime check the SQL queries that you're sending as a database are the kind of things that you expect to be sending? You can do runtime checks to make sure that they're not completely unexpected queries. You can do monitoring of things and just see if things that are out of the ordinary are happening, and just kind of be alerted and have a look and see if something peculiar is going on. As a developer, you need to be thinking about how when you're building something, how do I tell if someone's either trying or succeeding in escalating their privileges or doing something that your service didn't do, that if you try and do least privilege, but you can't always completely control exactly what things can do because it's complicated. At least you can monitor rather than just assuming that the world is a perfect place and everything's running exactly as expected. We've got time for questions. My presentation will be available on with Docker Pool as soon as I've uploaded it after this. Feel free to email me if you have security questions or issues. Feel free to either email me or if it's a real security problem, you can email security@docker.com if it's a vulnerability. If you feel free to just open issues on the Docker GitHub issue tracker, and if they're security related, I'll quite likely be me who answers them. If you just feel free to ask questions and things like that as well, because we know that getting security right is hard, and we're happy to help people out. And it's really important to try and help everyone along on this kind of journey of making every application more secure, and trying to not be the person who uses software with old security vulnerabilities and makes the kind of obvious errors. At least let's try and at least try and stop the basic things that account for most of the vulnerabilities, and try and improve our processes to deal with the more difficult things as well over time. But yeah, if you want to contribute, that's really good. As I said, a lot of the security changes in Docker come from outside people, and there's loads more that can be done if you're interested in working on things like that. But check out some of the stuff and try and improve your security processes. And I'll be around if you want to ask questions afterwards, or if you've got questions, time for questions now as well. Any questions? Yeah.
Using the keychain for logging into a Docker registry,
Yeah.
is that about to become the default anytime soon?
Hopefully, I think we're planning to add support to it for Docker for Mac and Windows as soon as possible. The reason we hadn't done it before was that Docker Compose didn't support the keychain properly. The 1.9 release of Docker Compose, which is out next week, does. So that was the kind of blocking thing. So hopefully, hopefully everyone can switch to doing that, because it's much more useful and secure. Yep.
It seems like it's a quite custom install, and for the other users in my office, I might have to actually go in and manually install certain plugins for it to work on Linux. Because out of the box, it seems like the configuration is storing clear text.
The out of the box, yeah. So the Linux on Linux, yeah, we do probably need to. I know that someone is working on Linux integration for making things kind of work well for Red Hat initially. So I'll make sure that that's one of the things they work on. I think they will be working on doing it for Ubuntu as well, which hopefully will be and Debian and so on, because. But I think it was kind of delayed because Docker Compose didn't support it. Lots of people couldn't use it anyway, so we couldn't really force it to be the default. So it's kind of annoying. But now that's fixed. Yeah, it's absolutely. Yeah, it's basically. Yeah, it's. The current the non-keychain solution is, as you say, it's a trivially. It's just a base64 encoding of the username and password, which is not at all what you want. But yeah, feel free to open an issue on Docker and say it's too difficult to use on Linux, and we can work out how we can get that fixed, because it is absolutely important. Yeah.
Do you have any advice on how to handle exposes from inherited images? So if you have an inherited image that exposes certain ports, and you might not need them, but it doesn't seem like there's any clear-cut way of not exposing?
Yeah, I think a lot of the inherited things turned out to be kind of not that great a design. And I think that probably less things should have been inherited, or things should have been explicitly marked as inherited rather than just inheriting by default. And I think that my advice would be to generally, for most things, is not to use expose in images that you're inheriting from, and just use them in the final image. But again, do raise if there might be an issue already for having a way of turning it off. But if there's not, it's definitely something that's been discussed with reference to definitely something else in the Docker file that is really inconvenient if it's and I think we've added some ways for some of the things of disabling inheritance, but I'm not sure what the current status with expose is. But yeah, I mean, for the moment, I think try not to put it in the base image at all. But some of the things like the Nginx base image do have expose, which again means you might, if you do want to change that behavior, you might have to fork the base image to change that at the moment, which is kind of annoying. So yeah, it definitely should be improved. It's also probably quite a fun, if you want to contribute to Docker, that's something you could work on. It's actually probably quite a fun beginner project because it's not. I think we could probably work out a design quite easily, and then actually implementing it's not that difficult. And it's everyone knows that it should be done. Okay, well, we're almost out of time. Feel free to come and ask me questions anytime. I'm around, or email me, or whatever. Yeah. Thanks.